Hi there, my name is Curly Johnson and I'll be taking you through another math fundamental. The title of this unit standard is Work with a range of patterns and functions and solve problems. Unit standard 9007, NQF2, 5 credits. The specific outcomes for this unit standard are convert flexibility between and within various representations of functions. Compare, analyze, and describe the behavior of patterns and functions. Represent situations mathematically in order to interpret and solve problems. Our first topic is number patterns, an ordered set of numbers, shapes, or other mathematical objects, arranged according to a rule. So our aim is to figure out the rule and apply it to find the numbers which follow. So our very first example is a very basic example. We have the numbers 1, 3, 5, and 7. So you can see the sequence between the numbers. The sequence is 2 plus 2 plus 2 plus 2. Therefore, because it is a number pattern, this applies to all of the numbers. So the rule is plus 2. Plus 2 will give you 9. Plus 2 will give you 11. Plus 2 will give you 13. So let's take a look at a second example. In this example, we have the numbers 20, 17, 14, 11, and 3 unknown numbers. The trick is to find what are the 3 unknown numbers. In order to find that, we need to find out what is the rule. In this case, our rule was plus 2. It was very clear. Now let's find out what this rule is. So, for 20 to become 17, we minus 3. This is a rule, but does it apply to the other numbers? For 17 to become 14, we minus 3. Can you see the pattern? Therefore, in order to find these 3 numbers, we follow the pattern. 11 minus 3 gives you 8. 8 minus 3 gives you 5. 5 minus 3 gives you 2. And that is our number pattern. So let's take a look at a more tricky example. If we are given the numbers 5, 5, 10, 15, and 25. So let's find the number pattern. So let's look at this number pattern a little bit differently. So over here we can see 15 plus what gives us 25? 15 plus 10. So these two values added together gave me 25. Let's test this theory. 5 plus 10 gives me 15. 5 plus 5 gives us our 10. So let's apply this theory to find out what these 3 values are. So the next number after 25 will be 25 plus our previous number, 15, and that will give us 40. How do we get the next number? 40 plus the previous number, 25, that will give us 65. And our last value, fortunately, we only need these 2 values, so I don't have to go all the way over there. 65 plus 40, that will give us 105. Now we have figured out our number pattern. So our next topic is drawing a graph. So graphs are drawn on a Cartesian plane. A graph has 2 axes. The horizontal axis, which is the x-axis, and the vertical axis, which is the y-axis. So let's draw a Cartesian plane. We have the y-axis, and we have the x-axis. So what's important to know here is that where they meet in the middle is our origin. And origin is equal to 0. So in other words, where x and y are both equal to 0. So let's look at a point whereby y is equal to a value like, let's say 3. This point will be plotted here, because this is where our values for y is positive. If we have a value like x is equal to 2, this is where we'll plot it, because this is where x is positive. So, as you guessed it, this is where x is negative, and this is where y is negative. So let's draw the positive values for y. 1, 2, 3, 4, 5. Okay, so we have 1, 2, 3. Y equals 3 is over here. 1, 2, 3, 4, 5. X equals 2 is over here. Keep in mind, over here, the y value hasn't changed. Y is still equal to 0 and x is equal to 2. And on the y-axis, on this point, x is equal to 0 and y is equal to 3. So continuing with graphs, let's look at the formula for a straight line graph. Y equals mx plus c. So let's look at an explanation of the formula y equals mx plus c. So let's look at these variables. Y is our y value. M is the gradient. So it is the slant of our line. X is our independent variable, as we know. And c is where the line intercepts the y-axis. So if this is our y-axis, over here, this will be our c value. So let's take a look at a practical example. You'll be given a formula as y equals 6x plus 2. 2 being c, 6 being m. So let's draw up a table for the x and y values. So over here we have our x values, and here we have our y values. Over here we begin with 0. We go back to -1, -2, -3. And our right, we have 1, 2, 3. All of these represent our x value. In order to get our y values, we have to go back to the formula. We have to substitute these x values into this formula in order to get the y value. So let's look at when x is equal to 0. Y is equal to 6 times 0 plus 2. 6 times 0 is 0 plus 2. Therefore, y is equal to 2. So let's look at when x is equal to 1. If we substitute 1 over here, 6 times 1 is 6, plus 2 is equal to 8. If we substitute 2, 6 times 2 is 12, plus 2 is equal to 14. If we substitute 3, 6 times 3 is 18, plus 2 is equal to 20. So the same would apply when working with a negative value x. -1 substituted over here will be 6 times -1 gives us -6, plus 2 gives us -4. 6 times -2 is equal to -12, plus 2 is equal to -10. 6 times -3 is -18, plus 2 is equal to -16. So now that we have our table, we can draw a graph. In order to draw a graph, we need to know our range. So our range for x is -3 to 3. Our range for y, we need our highest y value and our lowest y value. Our highest y value is 20. Our lowest value is 16, -16. So over here we have a range between 20 and -20. So you'll notice that on my x-axis, I count it in ones. And on my y-axis, I count it in fives. For convenience, but they have to all be equal. What you do on this side, you do on this side of the y-axis. What you do on this side, you do on this side of the x-axis. So now we're at the fun part of plotting our points onto the graph. Let's look at the table. Where x is 0, y is 2. Where x is 0, y is 2. Where x is 1, y is 8. Where x is 1, y is 8. It'll be around about here. So let's skip. Where x is 3, y is 20. Where x is 3, y is 20. So in order to draw your line, you need at least 2 points on the graph. Let's test this model out. If we draw our line, do these points land on our line? So where x is -1, y should be -4. X is -1, y should be -4. So let's test the last variable. Where x is -3, y should be -16. So as you can see, my drawings may not be accurate, but our model works. So the next graph we are going to look at is the hyperbola. Now this is a little bit more of a complex situation. So let's say we are given a formula of xy equals 10. Remember, we need y as the dependent variable. In order to do that, we divide both by x, and we end up with y equals 10 over x, because these x's are cancelled out. So what's unique about hyperbolas is that x cannot be equal to 0, because 10 divided by 0 will be an error if you type that into your calculator. So let's look at these values. If x is equal to 5, x is equal to 2, and x is equal to 1. In this case, our y value would be 10 divided by 5, that will be 2. 10 divided by 2 will be 5. And in this case, 10 divided by 1, y is equal to 10. Forgot the equal sign over there. So let's take a look at the negative values. If x were -5, -2, or -1, we'd have the same values, just negatives. Y equals -2, y equals -5, and y equals -10. So when you look at the graph, you'll notice that the lines never touch the x or the y-axes, and that's a hyperbola. And when drawing a parabola, we use the same procedure that we use for linear and hyperbola. The formula might be a little bit different, but the steps remain the same. It's all about substituting the x value in order to find the dependent y value. My name is Curtly Johnson. I hope you had as much fun as I have, and I wish you all the best with the rest of this program.